So in the previous class, I have shown you the 40 questions in the assignment in projectiles. In the previous two classes, I have shown you questions from 1 to 40 in the assignment in projectiles. I have also shown you the answers for all the questions. Probably you may have to have checked up your working. Now in this class, I am going to start discussion of the questions. So in the first class, I will be discussing about 1 to 10 or 12 questions. In case you don't have any doubts in these questions, in case you are able to get the answers for all the questions in the first 12 questions, you can skip this particular class and you can switch out to the next class. Again, I am going to show each question and discuss the solutions or answers or working for these questions. Come on, look at the first question again on the screen. This I have discussed in the theory part. The path followed by one projectile as observed by another projectile is straight line. That is observation. Reason is the relative velocity between two projectiles at a given place does not change with the time. The correct answer is the first option. This I have discussed in the theory part. The path followed by one projectile as seen by another projectile at a given place is a straight line because the relative velocity between the two projectiles does not vary with the time. Then come on, look at the next question, question number 2. This is also absorption reason question. The body is projected oblique at an angle theta above the horizontal with initial speed u. Then look at the question number 2. If a body is projected oblique at an angle theta above the horizontal with initial speed u, then its speed at the instant when its velocity makes an angle alpha above the horizontal is u cos theta by cos alpha. So let us verify the working for this question. So the path followed by the projectile as seen by stationary observer on the ground is a parabolic path. In the present discussion, the initial velocity makes an angle theta with the horizontal. Let V denote the magnitude of the velocity at a particular instant when its velocity makes an angle alpha with the horizontal. The horizontal component of initial velocity at the point of projection, denoted by ux, will be equal to u cos theta. The horizontal component of final velocity at a point P in its path, denoted by Vx equal to v cos alpha. In the theory of projectile motion, I discussed that the horizontal component of velocity of projectile remains constant at all the instants during the motion under gravity. That means Vx will be same as Ux. That means V cos alpha will be equal to U cos theta. From this you get V equal to U cos theta by cos alpha. Therefore, in this question, both the assertion reason are true and the reason is the correct explanation for assertion. That means first option is the answer. Now look at the question number 3 here. A body is projected from the ground with an initial velocity of 30 meters per second at 30 degrees, 60 degrees to the horizontal. If g equal 10 meters per second square, the velocity of projectile when it is at a height of 25 meters from the ground is. So look at the question 3 again. The initial velocity of projectile is given to be 30 meters per second, and you are asked to find the magnitude of velocity of projectile when it is at a height of y equal 25 meters. above the horizontal plane of projection here. So again, I have given you the formula for velocity of projectile at a given height y above the horizontal plane of projection. The velocity of the projectile at a given height y above the horizontal plane of projection is given by v equal to root of u square minus 2gy. So here initial velocity u is given to be 30 meter per second. G is given to be 10 meter per second square. You are asked to find the magnitude of velocity of projectile when it is at a height y equal to 25 meters. As already discussed, the magnitude of velocity of the projectile at a given height is independent of angle of projection. So you simplify this, you get root of 900 minus 500 meter per second or root 400 meter per second. So get the answer as 20 meter per second. So 20 meter per second is the answer for the question. See the question number 4. The body is projected some angle to the horizontal. The vertical and horizontal components of its initial velocity being 60 meter per second and 80 meter per second respectively. G equal 10 meter per second square. Then the horizontal range is. So the vertical component of initial velocity, we denote it by uy, which is equal to u sine theta, that is given to be 60 meter per second. The horizontal component of initial velocity, which is denoted by ux or vx, which is given by u cos theta, that is given to be 80 meter per second. So horizontal range of the projectile is equal to horizontal component velocity into time of flight. Here Vx is the horizontal component velocity and capital T is the time of flight. The horizontal component of velocity of projectile remains same at all the instants throughout the motion under gravity. So Vx is same as Ux. Time of flight is given by 2ui by g or 2u sine theta by g. Ui is the vertical component of initial velocity. So the horizontal component of initial velocity is 80 meter per second. Vertical component of initial velocity is 60 meter per second. And g is given to be 10 meter per second square. So you get the horizontal range of the projectile is equal to 960 meter. Is the answer. In case you want to require more time to copy the solution of the problem, you can take a pause and copy the solution of the problem. Next, I would like to show you the question number 5. The minimum velocity of a projectile required to hit a target 120 meters away is. So the target is situated at a horizontal distance of 125 meters. So horizontal range r of the projectile in terms of initial speed u and angle of projection is given by r equal to u square sine theta by g. Or you can write u square equal to, that means the initial square of the initial speed for a given range r can be written as gr by sine theta. So in this problem, r can be taken as 125 meters and g is 9.8 meter per second square. So for given value of the range r, the initial speed required will be minimum when sin theta is maximum. The maximum value of sin theta is 1. So for given horizontal range R, the initial speed required to hit the target will be minimum when sin theta is 1, or 2 theta is 90 degrees, or theta is 45 degrees. So to find the minimum value of u square, you can take sin theta equal to 1. So minimum value of u square required to hit the target is g into r. So g is 9.8 meter per second square, and r equal to 125 meters. So this you can write it as 125. I can write 5 into 25. That will be 49 into 25 meter square per second square. So if you take we have perfect square factors. So u minimum is equal to 7 into 5 meter per second, or 35 meter per second is the answer. So in case you want to copy the solution of the problem, in case you need more time to copy the solution of the problem, you can take a pause and copy the solution of the problem. Next, I would like to discuss the next question, question number 6. So for the question number 5, 35 meter per second is the answer. That means second half is the answer. See the question number 6 there. Two bodies are projected with the same initial speed. One body is projected at an angle of 30 degrees and the other at an angle of 60 degrees to the horizontal. The rate of the maximum height reached is. This is a direct problem. So the maximum height reached here in terms of initial speed of projection is given by u sin theta whole square by 2g. So maximum height reached by the first projectile denoted by h1. That is u sin theta 1 whole square by 2g. Here theta 1 is the angle of projection for first projectile. So maximum height reached by second projectile, I denoted by h2. Initial speed u is same for both the projectiles. Theta 2 is the angle of projection for the second projectile. So if you divide h1 with h2, you get sin theta 1 by sin theta 2 whole square. So you can substitute here theta 1 equal to 30 degrees and theta 2 equal to 60 degrees. Next you can simplify it yourself. You can take sin 30 degrees equal to 1 by 2 and sin 60 degrees equal to root 3 by 2. So you get h1 by h2 is 1 by 3, or h1 is to h2 equal 1 is to 3. Next, I would like to discuss the next question, question number 7. So for question number 6, second option is answer 1 is to 3. Coming to the question number 7. 4 bodies P, Q, R and S are projected with equal initial speeds, having angles of projection 15 degrees, 30 degrees, 45 degrees and 60 degrees with a horizontal respectively. The body having shortest range is. So for a given initial speed of projection, the range is proportional to the value of sine to theta. So you can compare the value of sine to theta, because sometimes you can be even compared to the four ranges here. I denote the range by R here. The horizontal range in terms of the initial speed of projection, angle of projection is given by u square by into sine theta by g. So for a given initial speed of projection, the horizontal range is proportional to the value of sine theta. Suppose if R1, R2, R3 and R4 denotes the horizontal ranges for the four bodies PQRS, then R1 is to R2 is to R3 for given initial speed of projection. And write sine to theta 1 is to sine to theta 2 is to sine to theta 3 is to sine to theta 4. Theta 1 is the angle of projection for first body, that is given to 15 degrees. So theta 2 is the angle of projection for second body, which is given to be 30 degrees. Theta 3 is the angle of projection for third body, that is 45 degrees. Theta 4 is 60 degrees. So sine to theta 1 becomes sine 30 degrees. Sine to theta 2 becomes sine 60 degrees. Sine to theta 3 becomes sine 90 degrees. Sine to theta 4 becomes sine 120 degrees. Sine 120 degrees is same as sine 60 degrees. You must be knowing the formula in trigonometry. Sine 180 degrees minus theta is same as sine theta. So sine 120 degrees you can write 180 minus 60. Sine 120 degrees can be written sine 180 minus 60 degrees, that is same as sine 60 degrees. That means sine 120 degrees is same as sine 60 degrees. As you know, sine 60 is more than sine 30. Pause. So you can compare the values here. You can observe that sine 120 degrees same as sine 60 degrees. So therefore, R4 will be equal to R2. But sine 30 is the lowest value. Therefore, you can write R1 less than R2, and that is same as R4, which is less than R3. That means out of the four objects, the object P has the shortest range and object R has the maximum range. The second and fourth objects Q and S have equal ranges that lie in between. In case you are interested to copy the solution, you can take a pause and copy the solution. Otherwise, look at the next question, question number 8. A stone is thrown at an angle theta to the horizontal, reaches a maximum height h. The time of flight of the stone is, you are given four options in terms of the maximum height h. As I already discussed in the theory part, that the maximum height reached by the projectile in terms of its time of flight is given by h equal to gt square by 8. This I have discussed in the past with explanation. Therefore, 8h by g equal to t square. So time of flight in terms of the maximum height is root of 8h by g. So instead of capital H, here small h is used for maximum height. Root 8 we can write 2 root 2. So that will be the answer. If you want to copy the solution of the problem, you can take a pause and copy the solution of the problem. Already I have given the proof for the result h equal to gt square by 8. Then you see the question number 9 here. Two stones are projected with the same speed but making different angles with the horizontal. Their horizontal ranges are equal. The angle of projection of one is pi by 3. And the maximum height reached by it is 1 or 2 meters. Then the maximum height reached by the other in meters is. So here this problem comes under one of the special cases which I discussed earlier in the theory part. As I discussed in the past, in the theory part, in general, if two bodies are projected with the same initial speed u at different angles theta 1 and theta 2 to the horizontal, then their horizontal ranges will be equal if theta 1 plus theta 2 is 90 degrees. That means if two bodies are projected with the same initial speed u at different angles theta 1 and theta 2 to the horizontal, then their horizontal ranges will be equal if the sum of their angles of projection is 90 degrees or the two angles of projection are complementary. Therefore, in the given problem, it's given that both the bodies cover the same horizontal range. It's also given that they are projected with the same initial speed u. Therefore, conclude that theta 1 plus theta 2 equal 90 degrees or pi by 2. So one of the angles of projection theta 1 is given to pi by 3. So you can substitute theta 1 equal to pi by 3 on the left side. So you get theta 2 equal to pi by 2 minus pi by 3 or pi by 6 radian or 30 degrees. The maximum height reached by the projectile in terms of the initial speed of projection, angle of projection is given by h equal to u sin theta whole square by 2g. So maximum height reached by the first projectile, you can write u square sin square theta 2 by the second projectile, u square sin square theta 2 by 2g. Maximum height reached by the first projectile is given by u square sin square theta 1 by 2g. So ratio the maximum height reached by the second projectile to the maximum height reached by the first projectile will be sin theta 2 by sin theta 1 whole square. Here theta 1 is equal to pi by 3 means 60 degrees. Theta 2 is pi by 6 or 30 degrees. So sin 30 degrees is 1 by 2. Sin 60 degrees root 3 by 2. So you get h2 by h1 equal to 1 by 3. Therefore, you can write maximum height reached by second projectile is 1/3 of the maximum height reached by the first projectile. Maximum height reached by the first projectile is given to 1 or 2 meters. Therefore, maximum height reached by the second projectile will be 34 meters. So answer for the question is 34 meters. In case you are interested to copy the solution of the problem, you can take a pause and copy the solution of the problem. Next, I would like to show you the question number 10. For question number 9, fourth option is answer, that is 34 meter is answer. See the question number 10 next. The equations of motion. So projectile are given by x equal to 36 t meters and 2y equal to 96 t minus 9.8 t square. The t is in time in seconds. So here, in the case of oblique projection, the horizontal displacement in time t is given by x equal to u cos theta into t. You compare this equation with the first equation given in the problem, x equal to 36 into t. So you get u cos theta equal to 36 meter per second. Then second equation, displacement y in the vertical direction in the case of oblique projection is given by y equal to u sin theta into t minus half dt square. The second equation given in the problem is 2y equal to 96 t minus 9.8 t square. So if you divide that equation with 2, and compare this equation with this equation, you get g is 9.8 meter per second square, and u sin theta you get 96 by 2 means 48 meter per second. That is the vertical component of initial velocity. So you can divide the equation 2 with equation 1. So u sin theta by u cos theta will be 48 by 36. We get tan theta equal to 4 by 3. But you are not given theta as tan inverse 4 by 3 in the options. Theta is expressed in terms of sin and cos. So tan theta is 4 by 3. You can separately construct a right angle triangle where you get tan theta equal to 4 by 3. Tan theta you can write opposite side by adjacent side. So you can construct a right angle triangle with one angle equal to theta. Length of the side opposite to theta you can take 4 units. Length of the side adjacent to theta equal to 3 units. From Pythagoras theorem, length of the hypotenuse side root of 3 square plus 4 square are 5 units. So from that you get sin theta equal to 4 by 5. So theta can also be written as tan inverse 4 by 3 or sin inverse 4 by 5. If you want to copy the solution of the problem, you can take a pause and copy the solution of the problem. So you get answer is given as sin inverse 4 by 5. See the question number 11. The angle of projection of projectile for which the horizontal range and maximum height are equal. So as I discussed, the relationship between the maximum height reached, the horizontal range and angle of projection of the projectile, tan theta equal to 4h by r. So it's given that the range and maximum height are equal. So r equal to 4h, r equal to h. Therefore tan theta you get 4, or theta equal tan inverse 4. That's the answer for the question. But sometimes you may not be able to recollect this formula, in that case you can do by the alternate method. Particularly in case you are given this problem or similar problem in any board examination or in subject to question paper, you have to do by the alternate method. You should not use this result which is not discussed in regular board examination textbooks. So its maximum height and horizontal range are given to be equal. The maximum height in terms of initial speed of projection is given by u square sine square theta by 2g. The horizontal range of projectile in terms of initial speed u and angle of projection is given by u square sine theta by g. So you get sine square theta by sine 2 theta equal to u square by g into 2g by u square. So we can substitute here sine 2 theta equal to 2 sine theta cos theta. In sine square theta I can write sine theta into sine theta on the left hand side. So on the right hand side you get 2. So 1 sine theta you get cancelled. So you get sine theta by cos theta tan theta you will get 4. Or theta equal tan inverse 4. In case you are given similar problem in board examination, you are supposed to work out the problem by this alternate method only. In case you are given a similar problem in objective type of question paper, you can solve the problem by the first method. This question was originally given in the EAMCET entrance in the past in medical. So in case you are given in any objective type exam, you can use the first method so that you can solve faster. But in case you are given a similar question in board examination, you are supposed to follow the alternate method. If you want to copy the solution of the problem, you can take a pause and copy the solution of the problem. Next, look at the question number 12. The speed of a projectile at its maximum height is root 3 by 2 times its initial speed. The range of the projectile is p times the maximum height attained by it. Then p equal to. Now the magnitude of, in the theory of projectile motion, I have discussed that at the maximum height or at the highest point of the path of the projectile, the vertical component of velocity becomes 0. The actual velocity of the projectile at the highest point is same as the horizontal component of velocity. So magnitude of the velocity of the projectile at the highest point same as the magnitude of the horizontal component of velocity, which equal to, you can write u cos theta. That is given to be equal to root 3 by 2 times the initial speed u. So you get cos theta equal to root 3 by 2. Theta is the angle of projection of the projectile. So you get theta equal to 30 degrees. I have discussed the relationship between the maximum height reached, horizontal range and angle of projection of the projectile. So you can write tan theta equal to 4h by r. This relationship I have discussed in the past. H is the maximum height reached and r is the horizontal range. Then tan theta you can write 4h by r. So in this question theta is 30 degrees, so you can substitute theta equal to 30 degrees in the left hand side. And can carry r to the left side. So tan 30 degrees equal to 1 by root 3. So you get range of the projectile is 4 root 3 times the maximum height reached. It is written as, it is given that range of the projectile is p times the maximum height reached. So you compare this and this. You get the value of p as 4 root 3. So that's the answer. So if you want to copy the solution of the problem, you can take a pause and copy the solution of the problem. Next, I would like to show you the question number 13. For a projectile, the numerical value of the ratio of the maximum height to the square of time of flight is g equal to 10 meter per second square. As I discussed in the theory part, the maximum height reached by the projectile in terms of the square of the time of flight is given by h equal to gt square by 8. So h by t square is g by 8. So here g is given as 10 meter per second square. So h by t square will be numerically equal to 5 by 4. That's all. That's the working for the question. So first option is answer 5:4. Next, I would like to discuss question number 14. This question comes under one of the special cases which I have discussed in the class. So you can see the class notes I have given. See the question number 14, a stone projected with a velocity u at an angle theta with the horizontal reaches maximum height h. h1 when it is projected. When it is projected with a velocity u at an angle pi by 2 minus 2 theta with the horizontal reaches the maximum height h2. The relation between the horizontal range r of the projectile h1 and h2 is. This relationship we have discussed already in the class earlier. You will get the first option as the answer. So for this question number 14, I have discussed the working for question number 14, the first special case in projectiles, where you get the first option as answer. See the question number 15. Four bodies are projected with same initial speed at angles 25 degrees, 35 degrees, 45 degrees, 70 degrees to the horizontal. Their horizontal ranges are R1, R2, R3 and R4 respectively. The correct ascending order is. A bit similar question I have discussed. You have to compare the values of sine to theta here. So for given initial speed of projectile, the horizontal range of the projectile in terms of the initial speed u is given by u square into sine 2 theta by g. So for a given initial speed of the projectile, range of the projectile is proportional to the value of sine 2 theta. You have to compare the value of sine 2 theta here. So the angle of projection for the first projectile are denoted by theta 1. So sine 2 theta 1, you can write sine 2 into 25 degrees. That will be sine 50 degrees. Sine 2 theta 2 is sine into 35 degrees. That will be sine 70 degrees. Sine 2 theta 3 is theta 3, the angle of projection for third projectile, which is given to 45 degrees. So 2 theta 3 will be 2 into 45 degrees or 90 degrees. The angle of projection for the fourth projectile, fourth body, are denoted by theta 4, which is given to be 70 degrees. It is easier to compare the values of sine theta, sine 2 theta, if we express all the angles within 90 degrees, because sine theta increases from 0 to 1 as theta is increased from 0 to 90 degrees. Sine 140 degrees you can write 180 minus 140. Sine 180 minus 40 degrees. Or sine 180 minus 140 degrees you can write. Because there is one formula in trigonometry, as you must be remembering. Sine 180 degrees minus theta is equal to sine theta. So sine 140 degrees, you can write sine 180 minus 40 degrees, or that is same as sine 40 degrees. You can observe that the lowest one will be the last one, sine 40 degrees is less than sine 50 degrees, less than sine 70 degrees, that is less than sine 90 degrees. That means sine 2 theta 4 less than sine 2 theta 1, that is less than sine 2 theta 2, that is less than sine 90 degrees. So range is least in the fourth case. R4 less than R1, that is less than R2, that is less than R3. So that is the correct ascending order of the ranges is R4, comma, R1, comma, R2, comma, R3. So in case you are interested to copy the working or solution part of the question, you can take a pause and copy the solution of this question. So I am going to continue the discussion of the remaining questions from 16th onwards in my next class.